The final stage of your analysis of your individual dam site options is to look at how changing the dam height at your chosen site would affect the amount of water storage that you can have behind that dam. And what you need to do is to figure out what height of dam you need to provide the storage that you've calculated. And there's also something else to consider as well. So I'm just briefly going to talk you through how you do that. So the amount of storage that you will be able to have in the reservoir per unit height of dam will be unique to the site, because it will depend on the relationship between height above ground level where you locate the dam and the topography of the ground that will be submerged under the reservoir. So here's a basic diagram to illustrate what we're talking about here. So here we have our dam and we have our landscape behind it. You need to have a minimum water level behind your dam, and this is there in order to provide some allowance for sedimentation of the reservoir, but this is also to provide some constant head of water available to provide your compensation flow. This is specified for your project as being 5 meters of dam height, and the storage that is provided behind that is known as dead storage, because that is the minimum water level that is allowed, and there's no way to change that. Then above that minimum water level is what we call the active storage, and this is the storage volume that you have calculated to meet the demand with a 1% probability of it filling in any given year. So that is the value you've calculated there is the active storage. And so in order to figure out what height of dam you need, you're going to have to consider both the dead storage and the active storage. Now just a quick note about two other parts of this water balance. First of all, you would expect to lose water from evaporation from the surface of the reservoir, and you might expect to lose some from leakage from the base. Now, because of the particular circumstances of the valley and the additional levels of complexity that will be required for your calculations, we are saying that you don't have to consider evaporation and you don't have to consider leakage. These will be minimal compared with the broader volumes that you're going to be thinking about, and so you don't have to consider those as part of the feasibility study. Okay, so how do you go about determining the height of the dam in order to provide your active storage and this dead storage? Well, what you need to do is to identify something called the storage elevation curve for your individual dam site options. And you do this using the Earthon Valley Digital Terrain Model, the DTM, and Terrain 3D. Now I've provided these for you on Blackboard. The Terrain 3D is an executable program for Windows, and you feed into it the Earthon Valley Digital Terrain Model, DTM, as an input, and then you have to specify where you want to put your dam, and it will draw your storage elevation curve for the landscape behind your specified dam site. So once you've done this, you then need to figure out what height of dam you need in order to produce the active storage and also to produce the additional storage in the dead zone from the design specification given here.